Hello friends. Welcome to our channel Techno Boost. In last video, we have already seen one passive component resistor. Let's see one more. This video is on capacitor. In this video, we will see what is capacitor, how it works, how it is made, types and applications. A capacitor is a two-terminal, electrical component. Along with resistors and inductors, they are one of the most fundamental passive components we use. You would have to look very hard to find a circuit which didn't have a capacitor in it. What makes capacitors special is their ability to store energy. They're like a fully charged electric battery. Capacitors, as we usually refer to them, have all sorts of critical applications in circuits. Common applications include local energy storage, voltage spike suppression, and complex signal filtering. The capacitor's symbol consists of two lines, which are either flat or curved. Both lines should be parallel to each other, close, but not touching, and this is actually representative of how the capacitor is made. The symbol with the curved line indicates that the capacitor is polarized, meaning it's probably an electrolytic capacitor. More on this will be discussed in the types of capacitors. Each capacitor is built to have a specific amount of capacitance. The capacitance of a capacitor tells you how much charge it can store. More capacitance means more capacity to store charge. The standard unit of capacitance is called the farad, which is abbreviated F. How a capacitor is made. The schematic symbol for a capacitor actually closely resembles how it's made. A capacitor is created out of two conductive plates and an insulating material called a dielectric. The conductive plates are placed very close to each other, in parallel, but the dielectric sits between them to make sure they don't touch. The dielectric can be made out of all sorts of insulating materials: paper, glass, rubber, ceramic, plastic, or anything that will impede the flow of current. The plates are made of a conductive material: aluminium, tantalum, silver, or other metals. They're each connected to a terminal wire, which is what eventually connects to the rest of the circuit. The capacitance of a capacitor, how many farads it has, depends on how it's constructed. More capacitance requires a larger capacitor. Plates with more overlapping surface area provide more capacitance, while more distance between the plates means less capacitance. The material of the dielectric even has an effect on how many farads a capacitor has. How a capacitor works. We know that electric current is the flow of electric charge. When current flows into a capacitor, the charges get stuck on the plates because they can't pass through the insulating dielectric. Electrons, negatively charged particles, are sucked into one of the plates, and it becomes overall negatively charged. The large mass of negative charges on one plate pushes away like charges on the other plate, making it positively charged. The positive and negative charges on each of these plates attract each other, because that's what opposite charges do. But, with the dielectric sitting between them, as much as they want to come together, the charges will forever be stuck on the plate, until they have somewhere else to go. The stationary charges on these plates create an electric field, which influence electric potential energy and voltage. When charges group together on a capacitor like this, the capacitor is storing electric energy just as a battery might store chemical energy. At some point the capacitor plates will be so full of charges that they just can't accept any more. There are enough negative charges on one plate that they can repel any others that try to join. This is where the capacitance, farads, of a capacitor comes into play, which tells you the maximum amount of charge the cap can store. If a path in the circuit is created, which allows the charges to find another path to each other, they'll leave the capacitor, and it will discharge. For example, in this circuit, a battery can be used to induce an electric potential across the capacitor. This will cause equal but opposite charges to build up on each of the plates, until they're so full they repel any more current from flowing. An LED placed in series with the cap could provide a path for the current, and the energy stored in the capacitor could be used to briefly illuminate the LED. Types of capacitors. There are different types of capacitors like ceramic capacitors, tantalum capacitors, polystyrene capacitors, silver mica capacitors, polypropylene capacitors, electrolytic capacitors, supercapacitors, variable capacitors. Each type of capacitor will be discussed in details in next video. Applications of capacitors are decoupling or bypass, energy storage and supply, signal filtering. In next video, we will discuss the applications in details. Thank you for watching my video. Please like, share and subscribe to my channel. You can comment if you have any doubt, and you can suggest for our next video.